we'll talk about the female reproductive system. In my last lecture, I mentioned that female reproductive system performs more functions than the male reproductive system. Male reproductive system produces sperm, right? Male sex cell. Female reproductive system produces female gametes or sex cells. Those are called ova or oocytes or eggs. But female reproductive system also provides the support for fertilization, and after fertilization embryo is formed inside the female reproductive system. Embryo grows inside the female reproductive system and becomes a fetus. So maintaining the entire pregnancy is another function, very important function of the female reproductive system. So it is more complicated than the male reproductive system. You already know the parts of both male and female reproductive systems. Both male and female reproductive systems have gonads and accessory structures. Gonads are testes in male and ovaries in female, right? Those are called the gonads. And gonads produce gametes. What are the gametes? The sperm and ovum. So we can say gonads produce gametes. So primary reproductive organs are ovaries. Then accessory organs or structures in female reproductive system are uterine tubes, also known as fallopian tubes. Uterus. Uterus houses the fetus. Then vagina, which is also known as birth canal, and the external female sex organs include labius majus or labia majora, labius minus or labia minora, mons pubis, clitoris. Those belong to the external sex organs. So those are the parts of female reproductive system. Here you see those structures or organs in the picture. We are looking one half. This is the sagittal section. So you see half of the uterus. You see the uterine tube. You see the white organ here, which is the ovary. So you see one ovary because you are looking one half of the body. So you see one uterine tube. You see the half of the uterus, right? You see the vagina and external genital organs, labium majus or majora, labium minus or minora, hymen, clitoris. Those are the external genital organs. Now, you know that ovaries produce and release egg, and after the egg is released from the ovary, what happens? That tube, you see that tube is attached to the ovary. One end of the tube, the free end, is close to the ovary like this. So this is the ovary and this is the end of the fallopian tube like this. It's not directly attached, but there is a small gap there. And at the end of the tube, there are finger-like structures like this. You see in the picture, the white one is the ovary, and just above the ovary, you have that fallopian tube or uterine tube, but the end of the tube has finger-like structures. Those finger-like structures are called fimbriae. They are trying to capture the released egg. So ovum is released from the ovary and immediately fimbriae captures it and takes the egg inside the tube. And the tube, uterine tube or fallopian tube, takes the egg to the uterus. Okay, we'll talk about that. Just know that that's why the uterine tube, the end of the uterine tube is very close to the ovary, and other end is attached to the uterus because that egg is taken to the uterus. Okay. Also, another thing you see that there are a number of ligaments. Those white rope-like structures you see in this picture, those are the ligaments. They tie the organs to the body walls and keep the reproductive organs in right locations. So, to keep the organs in right position, you need those ligaments. So we'll talk about those ligaments too. So let's see the ligaments. Ligaments are held in place by reproductive organs, are kept in right place by several ligaments. Ovarian ligament anchors ovary medially to the uterus. So here in this picture you see the ovarian ligament attached to the ovary, one end, the other end is attached to the uterus. So this is the ovarian ligament, ovary to the uterus. Another one in this side, right? Then you have suspensory ligament. You see the upper left corner, that ligament contains the blood vessels. That ligament connects the ovary to the lateral pelvic wall. Now look at this. This is the lateral pelvic wall. These are lateral pelvic. So this is the pelvic cavity, you know that. So lateral pelvic wall. So from the ovary to the lateral pelvic wall. That's the suspensory ligament. Then you have a broad ligament, which is a flat membrane. You see in the left side, in the right side they have removed that. In the left side you see that flat membrane attached to the uterine tube, attached to the ovary, attached to the wall of the uterus and vagina. So that is the broad ligament. It's a flat connective tissue membrane and it supports all those structures. You have same in the other side, but they have dissected this in the right side. Another ligament, you see in the right side they have shown the round ligament. Round ligament attaches the uterus to the labius majus, in the back of posterior wall of labia majora. So it goes from the uterus to the back of the female genital part, labius majus. So those are the important ligaments and they help to keep the reproductive organs in right locations in the body. Otherwise they will move a lot. We'll talk about the ovaries, the primary reproductive organs. Ovaries are surrounded by a fibrous membrane that is called Tunica Albuginea. And Tunica Albuginea is also present in the testis. You have seen that when we talked about the testis. So it is a covering. Inside the ovary, you have two distinct areas. outer part is the cortex and inner part is the medulla. In the cortex, you have the follicles, many round structures. Those are called the follicles. So if you see inside the ovary, you will see, cut the ovary and see inside, you have outer part and inner part. In the outer part, you will see many round structures. And these round structures are filled with cells, many cells. Okay. And these are called the follicles. And inside the follicle, you have what? You have the most important cell. Among other cells, you have one most important cell that is called the egg or ovum or oocyte. Okay, so each follicle has many cells, but only one oocyte or egg or ovum or oocyte. Same thing. Okay. Now, these follicles are gradually getting bigger, that means growing and getting matured. So these are the earliest follicles, and then they grow, gradually get bigger and bigger. Okay, so we'll see those stages of maturation of follicles. Just remember that you have stem cells along the wall, and from the stem cells, first by mitosis, multiplication occurs by mitosis, same as spermatogenesis, and then the follicles grow. Now, this is the most mature follicle. Okay, so you have other cells, then oocyte or egg, and also you have a large cavity inside. This cavity is filled with fluid. So what happens? The most mature follicle has a lot of fluid inside, and it is pretty large. So it's like a ripe fruit. You know, fruits start from tiny, structure, then gradually gets big, and when it's ripe, it's soft, right? And ruptures to release the seed, right? Exactly same thing. Gradually getting bigger, and a lot of fluid accumulates inside, and at one point it ruptures. And when it ruptures, it releases the egg or oocyte to the outside. Okay, so egg is released to the outside of the ovary, and that is called ovulation. You all know ovulation is the rupture of the mature follicle, most mature follicle, and release of the egg, and that is called ovulation. Okay. And then what happens after the ovulation? The rest part of this most mature follicle, which is called Graafian follicle, you will see soon. Just know that Graafian follicle, the rest part remains inside the ovary, and becomes a yellow structure. A lot of fat accumulates inside it. That's why it looks yellow. And this is called corpus luteum. Luteum means yellow. So, the Graafian follicle or the most mature follicle ruptures and releases the egg to the outside of the ovary. That is called the ovulation. And then rest part turns to an yellow structure because of accumulation of fat, and now this is called the corpus luteum. Corpus luteum acts as a temporary gland, that means not permanent. It stays there for about 14 days, but there is a condition. If fertilization does not occur, so the condition is if sperm doesn't fertilize the released egg, then corpus luteum will stay there for 14 days to work as a temporary gland. But if this egg is fertilized by a sperm, then pregnancy starts, right? You know that if the egg is fertilized by the sperm, pregnancy starts. In that case, this temporary gland, corpus luteum, will decide to stay for about 3 months, much longer. Okay. Whatever the situation is, it will stay either 14 days or 3 months. So it is a temporary gland. Why we say it is a gland? Because it produces and releases 3 important hormones. Okay, 3 important hormones are released: estrogen, progesterone, and inhibin. So these 3 hormones are produced and released by this temporary gland, corpus luteum. Why these 3 hormones should be released? Because these 3 hormones will inhibit the pituitary from releasing the follicular stimulating hormone and luteinizing hormone. Those are needed for the growth and rupture of next follicle. So these 3 hormones will keep this inhibited. So another ovulation will not occur immediately. You know, if one ovulation occurs, then another sperm will fertilize another egg. So that is not good. So after one ovulation, there is a waiting period of about 1 month, because you see here corpus luteum is formed and it stays for 14 days. Then another follicle get mature and release. So it takes about 28 days. So after the corpus luteum is formed, it stays for about 14 days. If fertilization doesn't occur, or let's think that way, no fertilization has occurred, then what will happen? This corpus luteum will become a whitish structure. From yellow it turns to white and degenerates, destroyed. So get into small pieces and will be destroyed. Okay. So after 14 days it will be destroyed. Before it gets destroyed, the white structure that is formed, that is called corpus albicans. Corpus albicans. So corpus luteum is the yellow structure. It is active temporary gland, produces those hormones, and then before it destroys, it will turn to a yellow, like a scar tissue structure, turns to a white scar tissue like a structure, that is called corpus albicans, and then it is destroyed, disappears. So that's for 14 days. So now let's see the entire process what is happening in the cortex of the ovary, we can divide it into three parts. From here to here, this is called follicular phase. Makes sense because follicles are growing and getting matured. So this part is called the follicular phase. Follicles are growing and getting matured. And the duration of follicular phase is about 14 days. Okay, so follicular phase is about 14 days. It takes 14 days to get a follicle matured, and then next is what? Next is the rupture of the follicle, right? That is called ovulation. So number 2 is ovulation, the release of the ovum to the outside of the ovary, and that doesn't take day, it just rupture and the release. So we'll say 0 day. So that's the ovulation, this one. And then after ovulation, what happens? You already know, corpus luteum is formed and it stays there for about 14 days if pregnancy doesn't occur, and this is called the luteal phase. Makes sense because corpus luteum is there. Luteal phase, number 3. So those are the 3 phases of entire ovarian cycle. Those 3 phases belong to the ovarian cycle. What is happening in the cortex of the ovary? That entire thing is the ovarian cycle. And now you know it takes about 28 days because follicular phase is 14 days, ovulation 0 day, and luteal phase is about 14 days. So total 28 days entire ovarian cycle. Okay, so that's what is happening in the cortex of the ovary. In the medulla, you have the blood vessels and nerves. So blood vessels and nerves are present inside the medulla. The ovary, which blood vessel enters into the ovary? That is the ovarian arteries. Very simple. Testes, testicular arteries, ovaries, ovarian arteries. And ovarian arteries are the branches of the uterine arteries. And uterine arteries come from the abdominal aorta. Internal, you will remember abdominal aorta lower end divides into common iliac, then external iliac goes to the leg, internal iliac at that time I mentioned stays in the pelvic area. Remember that? Internal iliac. So from the internal iliac, uterine artery arises, and from the uterine artery, the ovarian arteries. Okay, now we'll see the ovarian cycle in this picture that I explained to you here. So here you have the follicles of different stages of maturation. So we will see what are those different stages of maturation. If you see from the left side, upper left, primary follicles, and then you have the secondary follicles. Secondary follicles, there are 2 types, early secondary follicles and late secondary follicles. The difference between early and late is, of course, early are smaller, the follicles, and late are larger because they are growing. But another thing, if you look the late secondary follicles, cavities start to appear inside the follicles, and those cavities get filled with fluid. So that's the late secondary. Cavities start to appear and get filled with fluid. And then what happens next? Those cavities join together to form a large cavity, and this large cavity is now filled with fluid, and this is the most mature stage, that is called Graafian follicle stage, also called vesicular follicle. Same thing here. This large one, the large big cavity you see filled with fluid. So this is the Graafian or vesicular follicle, like a very ripe fruit, ready to rupture, right? A lot of fluid inside it, and the seed is the egg, ovum, right? So you have only one egg or ovum, but also you have many other cells. You see these tiny cells, many other, but only one large oocyte or ovum. So that's the Graafian follicle stage. So if I write down the stages of maturation, the most earliest follicles, those are the stem cells here I mentioned. Those are the primordial follicles. So number one, these are the stem cells, remember, these are the stem cell stages. Then you have the primary follicles. Then you have early secondary. Early secondary follicles. Then you have late secondary, okay, follicles, and then the most mature are the Graafian follicles. Graafian follicles or vesicular follicles. Okay, so this is the most mature one, and this one is ready to rupture because a lot of fluid inside. So now two hormones help to grow the follicles here and rupture it. Those hormones come from outside. Which two hormones? Follicular stimulating hormone or FSH. Follicular stimulating hormone. Its name is telling you. This hormone stimulates the follicles to grow. That's why I called follicular stimulating hormone. Also called follicular stimulating hormone. Same thing. And another hormone is LH, luteinizing hormone. So these two hormones come from anterior pituitary in your brain, master gland. So anterior pituitary gland releases those two hormones. Follicle stimulating hormone mainly helps to grow the follicles, and luteinizing hormone, this one mainly helps in the rupture of the follicle. So when luteinizing hormone is released, suddenly plenty of luteinizing hormone from the pituitary, what happens? The Graafian follicle ruptures and releases the egg. Ovulation occurs. So luteinizing hormone is responsible for ovulation or rupture of the Graafian follicle. And to rupture the Graafian follicle, remember, anterior pituitary must release plenty of luteinizing hormone suddenly, quickly, and that is called luteinizing hormone surge. Surge of luteinizing hormone. Quick release of plenty of luteinizing hormone from the pituitary. That will cause the rupture of the Graafian follicle, release of the egg, and that is the ovulation. So now you see you got a number of hormones. Before these two, I talked about the corpus luteum, which works as a temporary gland. Remember that? Temporary gland, and remains in the ovary how long? 14 days if no fertilization occurs, right? But if fertilization occurs, pregnancy starts, then how long it will stay? 3 months. Okay? So, and this corpus luteum acts as a what? Temporary gland. Remember that? And produces how many hormones I said? 3. Estrogen, progesterone and inhibin, right? So those 3 hormones are produced by the ovary, because this is inside the ovary. So from the ovary. But these 2 hormones are produced where? In the anterior pituitary, right? In the brain, and coming to work on the ovary and helping in what? Growth of the follicles and rupture of the follicles, right? Which one is mainly helping the growth? FSH. And which one is helping the rupture? LH. Is it clear? Okay. Now you tell me, if I can stop, everybody have to answer. If I can stop the release of FSH and LH from the pituitary, then what will happen? If I stop the release of FSH, LH. No FSH, no LH. The follicles will grow or not grow? The rupture will occur or not occur? So ovulation will be stopped, right? And that's how that is one method of birth control. We inhibit the release of FSH, right? So the rupture ovulation will not occur. You can stop ovulation, right? So we can do that. And you have already learned, I told you, who stopped the release of FSH and LH, because you remember that corpus luteum produces estrogen, progesterone and inhibin. Those 3 hormones are released by corpus luteum to stop next ovulation for a while. That's why these are the hormones needed to inhibit the pituitary. Tell the pituitary, don't release FSH, don't rupture another follicle. Make sense? Keep it stopped for 14 days. Is it clear? Then after 14 days, when corpus luteum is gone, then these will start to release. Is it clear? And follicle will grow and rupture will occur. So every time the corpus luteum is being formed, producing those 3 hormones, estrogen, progesterone, inhibin, those hormones are telling the pituitary, don't release FSH, LH, okay, until I get destroyed, okay, the corpus luteum. So then corpus luteum is destroyed, pituitary start to produce those hormones and release, and another ovulation occurs, which is very important, because if that inhibition doesn't go to the pituitary, immediately after one ovulation, another will occur. Then immediately after, another will occur. Every day, ovulation will occur. So that should not happen. When the egg is released here on the Graafian follicle, this is the egg, and around the egg some cells of the follicle also get out. So these cells, those are just attached to the outside of the egg or ovum. Those cells are called the corona radiata. Corona radiata, like this. Okay, so ovum and some follicular cells come out during ovulation. Uterine tube or fallopian tube. The uterine tube has different parts. I mentioned before that the attached end is attached to the uterus. That's why it is uterine tube. And it has a free end. So it is like this. You see, if my body is the uterus, okay, so this is the uterus, and these two are what? Uterine tubes, right? So attached to the uterine tube, and other end is free, right? So this end is free, and in this free end, you say you have finger-like structures. These are called fimria, I mentioned. So finger-like structures are moving like this all the time, okay? And you have the ovary here. You see that ovary is here. So this is the ovary. These are fimbriae at the end of the uterine tube or fallopian tube. Now I already mentioned that when ovulation occurs, egg comes out, right? Ovum comes out, and fimbriae are always doing like this to capture the egg. So immediately the egg will be captured by the fimbriae. Is it clear? Will be taken inside the uterine tube. Then after the fimbriae, the area where the fimbriae are attached. See my hand. So these are fimbriae, and this is the area where the fimbriae are attached, right? So this area, kind of wide, this is called the infundibulum. So you see in that picture, infundibulum is just above the fimbriae. And then you have a turning like this. And that area is called the ampulla. You already have heard ampulla. Ampulla means dilated or wide tube. So where is the ampulla? The area where the uterine tube turns towards the uterus like this, and that area is kind of wider or dilated. That's why it is called the ampulla. And then you have the rest part of the uterine tube, and the part that is getting attached to the uterus, that part is constricted or narrow. That part is narrow, not wide. That part is attached to the uterus, and that is called the isthmus. So you see in the right side, you see the fimbriae, you see infundibulum, you see the ampulla, and the part which is narrow and attached to the uterus, that's the isthmus. Is it clear? So this is what? This is the uterine tube, right? So these are fimbriae, right? Trying to do what? Capture the egg or ovum, right? And then fimbriae are attached to the area that is called the infundibulum. Clear? Then the tube turns like this, and that area is called very important area. That is the ampulla. Ampulla means dilated or wider tube. Why I said ampulla is very important? Because in most of the cases, fertilization takes place in the ampulla, in this part. That means what? That means the egg is taken there from the ovary, so not too far, right? But sperm travels a lot, goes through all those parts, vagina, uterus, then different parts of uterine tube, and arrives in the ampulla. So sperm needs to travel a long distance, right? But egg is lazy, doesn't move too fast, just very slowly going to the ampulla. but sperm is fast. Why sperm is fast? Because it has flagellar tail, right? So it can swim, it can move in the fluid. If it was only round, won't have the motion. So that's why ampulla is very important. Most of the time fertilization occurs inside the ampulla. Now after fertilization, what happens? The fertilized egg start to move towards the house. House is what? Who is the house? Uterus. I mentioned it in my first few minutes. So let me draw. So this is the house, uterus, right? So this is inside the uterus, uterine cavity. There is a cavity, that's the uterine cavity. This is the wall of the uterus. Okay, so this is the ovary, egg is released, then egg is taken inside the uterine tube, and when the egg arrives here, this is the ampulla part, and sperm travels this way and arrives here and fertilizes the ovum or egg, right? So fertilization occurs in the ampulla, and then the fertilized egg, this is the fertilized egg. So now you tell me, in ovum you will have how many chromosomes? Haploid, half, right? You remember ovum and sperm, by meiosis the number of chromosome is reduced to half. We have talked about that in last class, right? Mitosis, meiosis. So only in the sperm and egg or ovum you have half number of chromosomes, right? So here you have half and sperm has another half. So from each parent, half. Then when the fertilization occurs, in this one you have 2n, that means double. That's the number in normal cells of the body. So you have diploid number of chromosomes. Then what happens? Mitosis starts, and this fertilized egg first divides into 2, then divides further to form 4 cells, then more and more. Okay, so while the fertilized egg is moving towards the uterus through the uterine tube or fallopian tube, what is happening? Cell division occurs by mitosis. Remember, all these are mitosis. So the number of cells increase by mitosis, and that structure is also moving towards the uterus. Okay, and we'll talk about that later. Just know that the fertilization occurs in the ampulla, and then fertilized egg starts to multiply by mitosis and move towards the uterus. Now, if for some reason this fertilized egg doesn't move, for example, got stick to the wall of the uterine tube, for some reason got stick to the wall of the uterine tube, not moving to the uterus, then what will happen? The pre-embryo and embryo will be formed here, and that is called ectopic pregnancy. That is false pregnancy. Okay? Anywhere outside of the uterus, if embryo is formed, that is ectopic pregnancy. Because embryo must be formed in the uterus. In that case, the embryo will eventually die, and sometimes what happens that embryo stays there and calcified the tissue and can eventually cause cancer. So you have to remove that embryo. Okay, makes sense? If it dies outside of the uterus. So that's the ectopic pregnancy. It happens. It can happen anywhere. I said outside of the uterus. Just see that after the ovary releases the egg, if the female cannot capture the egg, then sperm will come out and will fertilize it. So fertilization can happen here, or the egg can get attached to the outside of the uterus, right, outer wall, and sperm can find it and fertilizes it, and embryo will be formed here. So anywhere, if fertilization occurs, embryo is formed, right, it will eventually die. Initially, it will not die. The reason is what? The egg is very big. Remember, eggs are many 100 times bigger than the sperm. So your egg is like this compared to the sperm. And egg stores what? You all know that. Why you eat egg? It stores proteins and fats, right? That yellow. So that means what? Energy. So egg stores lot of nutrients. Is it clear? For what? Why egg needs to store a lot of nutrients? Not for you, okay? For the sperm and multiplication after fertilization, because multiplication occurs very fast, right? Metabolism and lot of nutrient and energy is needed. Fats provide energy for multiplication and metabolism, and proteins are needed to form new structures. That's why in all creatures, you know, including the chicken egg, right? It is so big. It is just an egg or ovum. So big, right? Sperms are very tiny. And why it is big? Because it houses stores a lot of nutrients. Okay. So that's how the fertilization occurs. Now we'll see the uterus. If you see the uterus, it is a house I mentioned, and there is a cavity inside it. That cavity is called the uterine cavity or cavity of uterus, also called lumen of uterus. Most of the time we say uterine cavity. And the uterus has different parts. The top part between two uterine tubes, you see here two uterine tubes, between those two, the top part of the uterus is like a dome. That dome shaped part is called the fundus. You have seen the fundus in the stomach too, right? So that's the fundus. Then you have the body part. Then you have a constricted area here. After the body, it gets constricted, and that constricted part is called the isthmus. You remember, isthmus is also present in the uterine tube. I mentioned at that time, constriction is called isthmus. So you have the isthmus here, this area, constricted. So fundus, body, and then this constricted part is the isthmus. And then the lower end is called the cervix of the uterus. So below the isthmus, the lower end is called the cervix. Now, inside the cervix, the passage is called the cervical canal. Very simple. Inside the cervix, that's why the canal is called, or passage is called the cervical canal. So then cervical canal has two mouths. We say mouths, or kind of constrictions. Upper one is called internal os, OS. Lower one is called the external os. Internal is the upper, inner one. External is the lower or outer one. The word os means mouth. So mouth-like structures. Uh, in between two osses, you have the cervical canal. Now, those are the parts: fundus, body, isthmus, and cervix. And the wall of the uterus has three layers. If you see from outside to inside, outermost layer is the perimetrium. Peri means around, perimeter. We always use that term, perimeter. So perimetrium is the outer layer, and then middle thick layer is the myometrium. Myo means muscle. So middle thick muscular layer is the myometrium, and innermost layer, this is the most important layer because fertilized egg comes and stick in it. This layer is called the endometrium. So all are metrium: peri, myo, and endo. Endo is inside. So those are three layers, but I mentioned that endometrium is very important because the fertilized egg comes inside the uterus and gets stick to the endometrium, and that is called implantation. Implantation. When you make a garden, this is the time you first make a soft bed, right? Lot of soil you put and put water, right? Fertilizer, make it nice soft bed. Then you put the seed. Exactly same. The uterus is doing what? Making nice soft bed so the fertilized egg can come and get implanted there, stick there into it. So that is the implantation. And so it is like, if you invite your friend to come to visit you, okay, so you got spring break or summer break, your friend called you and said, I'm coming to see you, right? You get excited. Not all the time, but get excited. My friend is coming, right? And what do? You clean the house, make soft bed, nice soft bed, right? To make your friend comfortable. And then you go to the airport to receive your friend and together come to your house. Make sense? So exactly same thing is happening here. You are going to the ampulla, your friend is coming at the ampulla, okay? So you are meeting there with your friend, and that is the fertilization, right? Fertilization, and then you together coming back to your house. Who is the house? Uterus, right? And who is the bed, soft bed? The endometrium, right? The nice soft bed. So the U2, that means the fertilized egg, will stick in that bed. Okay, that is called the implantation. Now you tell me, if you go to the airport and see no sign of your airport, you are calling, no response. Okay, and everybody has gone, like all passengers have left, no sign. So what you will do? You'll come back to your house, right, and destroy the bed. You get angry, right? So every time, most of the time, fertilization doesn't occur, right? So what happens? The uterus destroys the bed, gets angry and destroys the bed, and that is called menstruation, destruction of the bed, and the destroyed things come out from the body. But if your friend comes, then you'll keep the bed, right? So uterus will keep the bed, will not destroy the bed if fertilization occurs. Okay. So that's the story. So here you see the parts of the uterus: fundus, isthmus, body, cervix, cervical canal, and two osses, external and internal osses, and three layers in the wall. perimetrium, myometrium, endometrium. Now, endometrium, the inner layer of the uterus, has two sublayers in it. So endometrium has two layers. What are those two layers of the endometrium? The stratum basalis and stratum functionalis. This is the stratum functionalis and this is the stratum basalis. Two layers in the endometrium. Remember, we are talking about the innermost layer of the wall of the uterus. So endometrium has stratum functionalis, stratum basalis. Stratum functionalis or functional layer is not fixed. It is changing. And stratum basalis, this layer is fixed, will not change. Okay? So fixed layer is the stratum basalis and the layer which is changing, that's the stratum functionalis. So what happens if fertilization doesn't occur? This stratum functionalis is destroyed. So this is stratum functionalis. If fertilization doesn't occur, it will be destroyed. Almost whole stratum functionalis layer will be destroyed. This is the soft bed. And then your uterus will again start to form the bed. And if fertilization doesn't occur again, it will be destroyed. So that is happening. Okay? The functional layer is being formed and destroyed. Formed again and destroyed. So we'll talk about this in next lecture. That is called the menstrual cycle. Destruction and formation of the stratum functionalis of the uterus. Now, if you see the blood supply in the wall of the uterus, which is very important, uterine arteries come from internal iliac. Let me write down here. You already know external iliac, internal iliac. So internal iliac, you must remember that, the pelvic area. Then from internal iliac, you get the uterine artery. Then from the uterine artery, you get the arcuate artery. You have seen arcuate in the kidney, right? Also, you have arcuate here. So from uterine artery, branches arise, those are arcuate arteries. And from the arcuate artery, now you see the branches go to the stratum basalis. So from arcuate, you see the arteries arise, those are the radial arteries. You must remember in the kidney, arcuate and cortical radiate, remember that? How many of you remember arcuate artery inside the kidney? Along the base of the pyramid, right? And cortical radiate artery, right? So similar, arcuate and radiate, right? And then from the radiate, two types of arteries are formed. So this is the radiate artery, and from radiate we see spiral artery and straight artery. So spiral and straight. So some arteries are straight and some arteries are coiled, spiral. Now let's see. You see, this is the radiate artery, and straight arteries, spiral arteries. Okay. Now, this is the stratum functionalis. This is the stratum basalis. The spiral arteries go to the functional layer, stratum functionalis. And what happens? Constriction of the spiral arteries. Strong constriction of the spiral arteries stop the blood flow into the stratum functionalis here. So when the spiral arteries get heavily constricted, almost no blood reaches to the stratum functionalis in this part, and that part is destroyed because no oxygen, no nutrition. So that's the mechanism of destruction of functional layer. Strong constriction of the spiral arteries. So no blood circulation will occur, right? No blood will flow there. That tissue will be destroyed. Is it clear? And will be shed out. So that is the menstruation. Now the question is, who causes the strong constriction and again, the constriction of the spiral arteries? That's the hormone. Hormones. That's why, in female body, the hormonal changes occur every day, very fast during the cycles. So estrogen, progesterone, those two hormones, the amount or concentration changes in the blood all the time. So we'll talk about that. Just remember that hormonal change causes that constriction of the spiral arteries and destruction of the functional layer. Okay. So remember these arteries: internal iliac, uterine, arcuate, radial, and straight, and spiral arteries. Spiral arteries supply blood to the functional layer. Okay, so let's stop here today. We'll finish in next lecture.